X-Noise is part of the Waves Restoration Bundle, and it mainly targets background noise such as tape hiss and unwanted room noises. It is a single-ended real-time noise reduction tool that doesn't require the encode-decode process such as other popular noise reduction tools. Instead, it uses frequency domain analysis to detect and reduce unwanted noise from the source audio with a minimum of induced artifacts. Being a real-time process, you can hear the results immediately. Make sure to treat transient noise such as pops from an old LP with X-Click and possibly X-Crackle before using X-Noise. X-Noise works by learning the character of the noise and creating a noise profile which helps distinguish the noise from the audio signal. It uses the latest in audio research and processing power enabled by a new generation of powerful desktop computer systems to remove unwanted noise and preserve sonic clarity. Let's check out the controls using a noisy guitar track as our example. It was recorded in a live club with a large refrigeration unit directly behind the stage. It was emitting so much EMF that it made this single-coil Stratocaster buzz like a swarm of bees. We need to select a portion of the signal, at least 100 milliseconds, where the noise is by itself. This is usually at the beginning, ending, or sometimes a break within the song. We were fortunate to be running constantly and were able to capture a fair amount of noise without the music. While playing from the beginning, hit the Learn button to begin the learn process, and then again to stop the process. The white line that is generated on the graph dictates the noise profile. Make sure not to have any noise reduction active while using the learn process. You can then adjust the threshold and reduction settings to separate the noise profile from the original audio. The threshold represents the level of the noise profile, and the signal below this profile is removed, while the signal above is not affected. Reduction determines the amount of noise reduction applied to the signal below the threshold. Try setting the threshold at 20 decibels and the reduction to 75% to begin experimenting. It is crucial that you use your ears carefully to adjust this plugin. Make sure to use the audio difference output button to actually solo or isolate the noise signal that is being removed from the audio. The trick here is to have it so none of the musical or pertinent audio is affected by the noise reduction. In difference mode, you can listen for this and tweak the settings to lessen the effect of the source audio. If time aliasing artifacts such as singing or robot-like sounds occur, try decreasing the reduction setting and increase the threshold setting to about 30 decibels above the background noise. These artifacts can also be decreased by using the attack, release, resolution, and high shelf controls. The attack control adjusts the time from when the noise is first detected to the point of full noise reduction. Noise reduction is smoothly increased to avoid pops and clicks from occurring due to the DSP processing. The default time of 30 milliseconds works for most applications, yet plosive sounds may require a shorter setting, and audio with a slow dynamic envelope may require a longer setting. Release controls the rate at which noise reduction is smoothly decreased from its full effect. Longer times preserve more ambience, and shorter times are useful in removing noise in speech for forensic or other restoration tasks. The high shelf is a noise profile modifier. It is not another EQ in the signal chain. Boosting high frequencies of the profile will require more reduction of that particular spectrum. It is only used to modify how X-Noise works on the high frequency. The frequency control ranges from 400 Hz to 20 kHz, with a default of 4006 Hz. The gain control affects the attenuation applied to the high-frequency content. An increase of gain yields a higher threshold for the frequencies above the shelf cutoff frequency. Therefore, more noise reduction occurs in that spectrum. Decreasing the gain lowers the threshold and therefore lessens the gain reduction in the high frequencies. The resolution controls how fine the analysis is, which affects the amount of CPU horsepower used by X noise. The high setting uses the most CPU resources and results with the best audio signal. It is also the finest resolution in the frequency domain, but not in the time domain. If you hear smearing artifacts, make sure to lower the resolution. The noise reduction meter shows the level of noise removed. It also shows the sound level monitored with a different setting. The main display window shows 3 frequency graph lines. The red line is the original audio signal before X noise. The white line is the noise profile. And the green line is the output signal post X noise. Once again, make sure to use your ears. Headphone listening is recommended for fine-tuning in certain applications. Let's take a moment to tame this noisy guitar track.
You got to help me, baby. I can't. I got to use somebody else. Bring my
As you can see, X noise can restore a track that might have been otherwise deemed unusable, and is a very valuable tool in your audio production toolkit. For additional information, check out the Plugins movie library at coolschoolonline.com.